So the question says, which lines are perpendicular to y equals 1/2 x plus 3? Select the equations you want to choose. So first, the given equation, which is right here, this is in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept, where the graph crosses the y-axis. So we are looking for which of these given equations are going to be perpendicular to this given equation. So if you remember, perpendicular lines, right? The slopes are opposite reciprocals. So remember, opposite means if one's positive, one's negative. Reciprocal is when you flip that fraction. You flip the numerator and the denominator. So the given equation is y equals 1/2 x plus 3. So I can see here that the slope is 1/2. So if I want a line that's perpendicular to this, so a line perpendicular will have a slope that's equal to, it has to be the opposite of 1/2, so it would have to be negative, and reciprocal means I'm going to flip it, so it would be 2 over 1, which is the same thing as -2. So if I can find an equation that has a slope of -2, then that would be perpendicular to this given equation, which has a slope of 1/2. So again, opposite reciprocals, that's how you find lines that are perpendicular. So I think the easiest thing to do is to take all of these given equations and to put them all in slope-intercept form, because then you can easily find the slope. The slope would be the coefficient of the x. So if I can find the coefficient of the x, that's going to be my slope. And anytime I can find a slope of -2, that's going to be perpendicular. So let's take our equations. So I'll take the first one. First equation is y equals 2x plus 3. So I can see right here that the slope is equal to 2. So if this line has a slope of 2, and the given equation has a slope of 1/2, are those going to be perpendicular? They are not, because they have to be opposites of each other. They're both positive, so they're not opposites. So I know right now that the first one is not a possibility. That's not going to be perpendicular. So I'll take my second equation, going across. The second equation was 2x plus y equals -1. So this is not in slope-intercept form, so I'm going to put it into slope-intercept form, which means I want to get the y by itself, so I need to get rid of this 2x. So I do that by subtracting 2x from both sides. And when I do that, 2x minus 2x cancels, and I get y is equal to, I'm going to put the -2x, I'm going to put that term first, and then I'm going to subtract 1. So this is in slope-intercept form now. And I can see that my slope right here is equal to -2. And that's the slope that I'm looking for, right? This has a slope of -2, and the given equation, if you remember, had that slope of 1/2. Those are opposite. One's positive, one's negative, and they're also reciprocals. Because remember, if you flip that 2 over 1, if you flip the 1/2, you get -2. So this equation is going to be perpendicular. So I'm going to circle that one. So if I go to the third equation, going across, that was y equals -1/2 x plus 4. This one's already in slope-intercept form, so I can see right here that my slope is equal to -1/2. Is that the slope I'm looking for? Nope, because remember, I was looking for anything that had a slope of -2, right? Opposite reciprocals. So this is not going to be, oops. So I can cross out this one as well. So let's go to the next one. Y equals -1/2 x minus 3. So I'll write that down here. Y equals -1/2 x minus 1/3. Already in slope-intercept form, the slope is negative 1/2. And does that have a slope that's the opposite reciprocal of the given equation? No, it does not. So I'm going to cross this one out as well. All right, so I erased some of that other stuff, but again, this equation, remember, has a slope of 1/2. So what we are looking for is we're looking for a slope that's the opposite of that, which would be negative, and the reciprocal of that, which would be 2/1. So this is the kind of slope I'm looking for that would be perpendicular to the given equation. So let's go to this next one. I've got y equals negative 2x minus 5, already in slope-intercept form. So the slope is equal to negative 2, and that's the slope I'm looking for. That's the opposite reciprocal of the given equation. So this would be perpendicular to the given equation. And then our last one here is 2x minus y is equal to 6. So this is not in slope-intercept form, so I'm going to put this one in slope-intercept form. So I'm going to subtract 2x from both sides. 2x minus 2x is 0, minus x is equal to negative 2x plus 6. That 0 I don't need, so I can just write negative y is equal to negative 2x plus 6. So it might look like it's in slope-intercept form, but we have to get rid of this negative here, because remember there's really a negative 1 there, so I'm going to divide everything by a negative 1. So then I get y equals, a negative divided by a negative is a positive, 2x, and then 6 divided by negative 1 would be a negative 1. So the slope of this line is 2. And is that the slope we're looking for? Close, but we're looking for a negative 2, and that's a positive 2. So if I go up here, I'm going to cross out this one also. So the two equations that that would be perpendicular to the given equation are the two that I have circled here, because remember, perpendicular lines have slopes that are opposite reciprocals of each other. Now, the problem didn't ask about parallel lines, but I'm going to talk about parallel lines as well, because that might be on the test also. So what if this question would have asked us for lines that were parallel? So parallel lines, if they gave us the same equation, y equals 1/2 x plus 3, and the slope of this line again is 1/2, so the slope is 1/2. If I wanted to find lines that were parallel to that, I would have to find lines that have the same slope, right? So parallel lines have the same slope. So what you would have to do is, again, if the equation is in slope-intercept form already, you can easily find the slope. If it's not in slope-intercept form, you would want to solve for y, get it in slope-intercept form, find the slope, and if two equations have the same slope, then they would be parallel. But again, just to review on this problem, the two lines that were perpendicular, these were your two answers.